The first line of a Balmer series occurs at the wavelength of 656.3 nanometers. What is the energy difference between the two energy levels involved in the emission that results in the spectral line? So we're given the wavelength. So there are two ways of answering this question since we're trying to determine the energy. One way would be using this formula. Okay, since we've got the wavelength, this formula is going to work. Just convert the wavelength to meters. But I want to introduce you to a new formula. So the formula is negative 2. Let me just work with it in the positive form. 2.18 times 10 to the power negative 18, and then 1 over the initial squared minus 1 over the final squared. So why am I saying this? So Balmer series involves the movement of electrons to the second energy level, because the first one is called the Balmer series. Now the first for the Balmer, it's the second energy level. So the first transition to the Balmer comes from the third energy level to the second. Okay, that's the first transition. So therefore the initial for the first to the Balmer series is 1 over 3, from 1 over 3 to 1 over 2 itself, which is involves Balmer series. So surprisingly, it's so interesting that if we try to calculate here, we're going to have in the brackets 1 over 9 minus 1 over 4 and then multiply by the 2.18 times 10 to the power negative 18. So the answer is negative 3.02. Let me just say 3 times 10 to the power negative 19 joules. So why is it negative? So by now you should know that whenever you're having a movement of an electron from a higher energy level to a lower one, energy is lost. That's why it's a negative. Now what about if you try the other formula? Remember, in this calculation we've not even used the wavelength we are given. What if we use the wavelength? Are we going to get the same answer, or is going to be different? So we can try it. So our energy is going to be hc over that. So 6.626, the Planck's constant, the power negative 34, multiplied by 3 times 10 to the power 8. This is over the wavelength, which is 656.3 times 10 to the power negative 9, because we are converting that to meters right away. So 6.626 times 10 to the power negative 34 multiplied by 3 times 10 to the power 8. So if we get to divide, we're going to get, so 656.3 times 10 to the power negative 9. So the value I'm getting there is 3.03 times 10 to the power negative 19 as well in joules. So you just remember that this was from the outer to the inner part, so it's a negative as well. So it doesn't matter actually. So any formula can work for this question.